So as I was grading your 8.5 questions on Edpuzzle, I noticed this entry from Dougie, which said, I wonder why, when factoring x squared plus bx plus c, you have to find two numbers whose sum is b and whose product is c. Now, I loved this question so much, I decided to make its own separate video just to answer this question, because it's so good. So, if we start out with this trinomial, x squared plus bx plus c, we'll notice it has a hidden coefficient of 1, since there's not really a coefficient right there. Our leading coefficient we can say is 1, which means if we want to factor this guy, we're going to end up with something times something else equals our trinomial. Now, since our leading coefficient is 1, to get this x squared, all we're going to do is multiply x times itself. It's not going to be like 4x times 3x or negative 2x times x. X times x is x squared. So we're going to start out with x and x. Now we need to figure out what is going to go here. Oh, wrong tool. We're going to figure out what's going to go here and here to get our plus bx plus c. So what I'm going to do is I'm going to put two substitute numbers. We're going to say m and n. These are our filler numbers for now. They could be anything, but we need to figure out what do m and n need to be in order to get bx plus c, in order to match our b and c from our notes yesterday. Well, let's go ahead and multiply this out. Sometimes you guys might want to do the FOIL method to multiply two binomials, which is the first times the outside times the inside times the last. In fact, I like that method. Let's do that. You could also distribute by taking x times x plus n and then m times x plus n. I think foiling in this case is going to be faster, so let's go ahead and do that. First, we have x squared. And then outside, we have x times n. Now, I like to write my letters in numerical, or not in numerical order, in alphabetical order. So we'll do n times x. And then we have m times x. And then finally, we have m times n. Okay? So we FOILed out our factors. Now we have this is going to end up equaling our x squared plus bx plus c. However, we have some like terms. You'll notice that we have x squared is by itself, mn is by itself, but we have two terms with just one x in them. So we can in fact combine these two guys to give us n plus m, and that has an x on the outside because we distributed out an x from each term. Equals x squared plus that plus mn. Now again, I like to write these guys in alphabetical order, so I'm just going to switch them around. X squared plus m plus n, x plus mn. Now this has always stayed equal to our x squared plus bx plus c. So if I bring this guy down here again, you'll notice it's following that same pattern. It's still a trinomial. We have x squared plus something times x plus something else. So that means we have to find two numbers that add up to b and two numbers that multiply to c. So here we know that b equals m plus n, and we know that c equals m times n. So this is why we are always going to find two numbers that add to b and multiply to c.